Okay, guys, welcome. Today we're going to talk about how to solve absolute value equations as well as inequalities. All right, so we'll first start off with equations and then we'll work our way towards inequalities. So to solve an absolute value equation, you basically have two possibilities, right? And just as a reminder, I want to just put a little small example up here that says if you know that the absolute value of something is 3, then you know that the thing inside the absolute value is either 3 or it's -3, right? If I take the absolute value of either of those, I end up with 3. So those are my possibilities for having an absolute value of 3. So if in one scenario, the absolute value expression is equal to a positive number, right? And if, it's possible that you may have to uh, make sure that the absolute value is by itself on one side of the equation, but most of the time that's usually already done for you. All right, but if not, you want to make sure that that absolute value is by itself. But anyway, if it's equal to a positive number, you're going to set the expression that's inside the absolute value equal to the positive and negative value on the opposite side. Right, so that's sort of like highlighting this fact right here. Now, on the other hand, if the absolute value is equal to a negative number, well, that's just no solution because you can't have absolute value be equal to something negative. Absolute value is always positive. All right, so let's look at a couple of examples. So here in part A, we have absolute value of 2x minus 7 is equal to 11. Now, my absolute value is already by itself on one side, and it's equal to a positive number. So that means that the thing that's inside this 2x minus 7 is either equal to positive 11 or 2x minus 7 is equal to negative 11. Right? So now we just solve each of these. So now for this one, we can add 7 and we get 2x is equal to 18. So then divide by 2 and we get that x is equal to 9. Okay, and then in our other one, if we add 7, we'll get that 2x is equal to -4. So divide by 2 and x is -2. All right, so you get two possible answers here, and you can verify that if you plug those back in, you'll get 11 in either case. Okay. So for part B, we have absolute value of x plus 8 is equal to 9. And again, absolute value is by itself, and it's equal to a positive number. So this means that either x plus 8 is positive 9 or x plus 8 is -9. So you can subtract 8 from both sides. For both examples, we'll just do them at the same time. On this one, I'll get x is equal to 1. And on this one, I'm going to get x is equal to -17. All right, so you get two answers for these. Last but not least, part C, we have absolute value of 3x minus 4 is equal to 7. Okay, so again, we have our absolute value expression by itself, and it's equal to a positive number. So this means that either 3x minus 4 is equal to 7, or 3x minus 4 is equal to -7. So if we add 4, we get 3x is equal to 11, and this would just give me x is equal to 11 over 3. And in this one, if I add 4, we get 3x is equal to -3. So that just leaves us with x is -1. So those are our two solutions here. Okay, so that's sort of some basic absolute value ones. Okay, now for part A in this one, sort of have the same idea, where we have absolute value of 2 minus x is equal to 6. Okay, so if we do what we did before, this just means that since our absolute value expression is by itself and it's equal to a positive number, this means that either 2x minus 8 is positive 6 or 2 minus x is equal to -6. So if we subtract 2, we get -x is equal to 4, So multiply both sides by -1 and we get x is -4. Okay, and then in this one, if we subtract 2, we get -x is equal to -8. Multiply both sides by a negative and you get x is equal to +8. Okay, part B, we have x over 2 minus 4 is equal to 5. And again, same deal. It's equal to a positive number, so we can say this is x over 2 minus 4 equals 5, or x over 2 minus 4 equals -5. So let's add 4 to both sides, and we'll get x over 2 is equal to 9. And then, of course, to get x by itself, we just need to multiply both sides by 2. So these 2's will cancel, and we get x is equal to 18. And then in this one, if we add 4, we get x over 2 is equal to -1. Multiply both sides by 2 will give us x is -2. All right, so those are our two answers for that one. Now, finally, in part C, we have something different. We have absolute value of x plus 2 is equal to -3. Now here, you don't want to say this is equal to two separate things. Here, you just want to say this is no solution. Right? And again, why is it no solution? Because absolute value can never be negative. Okay, so as soon as you have absolute value equal to a negative number, automatically no solution. All right, so that's the idea behind absolute value equations. Now, let's take a look at what happens when you now have absolute value inequalities. Okay, so you're still going to form two sort of separate inequalities here, right? So this means that if you have absolute value of x less than or equal to something, then that means that x is either less than a or x is greater than -a. And then if this is the other way, if this is x, this is x greater than a, then that means that either x is greater than a or x is less than -a. All right. Now, what really is happening here, we have that in one inequality, you're keeping the positive number and you're keeping the sign the same. Right? Or you could even think of it as you're just sort of keeping whatever you started with, but you're taking out the absolute value. And the second one, you're switching the sign and you're using the negative number. Right? And then, of course, there's also the fact that if you mix in some negatives here, you could potentially either have all real numbers or no solution, right? If you have something in absolute value, you want to know when it's greater than a negative number. That's always true, right? Or if you have absolute value, you want to know when that's less than a negative number or 0 even. That's never true, so there's no solution. All right, so just some things to think about here. But let's do a couple of examples. So in part A, we have absolute value of 2x minus 5 less than or equal to 7. All right, so that number on the other side is positive, so that's when we sort of do our usual thing that we think. So here, on one of them, I'm going to leave my inequality sign the same and use the positive number. And on the other one, I'm going to switch the direction of the inequality sign and use the negative number. Okay, so in this first one, if we solve, we add 5. And we get 2x less than or equal to 12. So then when I divide by 2, I'm going to get 12 divided by 2, or 6. Now on this one, if we add 5, right, we're going to have that the 5's cancel, and we get that 2x is greater than or equal to negative 2. Right, so then we can divide both sides by 2, and we get x is greater than or equal to negative 1. Right, now since we have inequalities, we can graph the solution set. We have negative 1 down here, 0 over here, and 6 up here. It looks like both are going to get a closed circle. And we want what's in between them. All right, so something like that. Okay, now how about, let's see, I'll give myself a little more room. So now in part B, we have absolute value of x less than 3. All right, so now this will kind of work out much easier since there's no algebra. This just tells us that either x is less than 3 or x is greater than negative 3, right, almost immediately. So on our number line here, both are going to get open circles. And again, since we want stuff less than 3 but greater than negative 3, we're going to shade in between here. Okay, so that one's nice and simple because there was no algebra. So for part C, we have 3x minus 1 less than or equal to 8, I believe, right? Yeah. Okay, so my number on the other side is positive. So business as usual, 3x minus 1. Keep the sign the same, keep the positive number. And then also 3x minus 1. Flip the sign, use the negative number. All right, so now let's just solve each of these. So this one we can add 1, and we get a 3x less than or equal to 9. And then dividing by 3 is going to give us x less than or equal to 3. And then, of course, in the second one, if we add 1, we get that 3x is greater than or equal to negative 7, which gives us that x is greater than or equal to negative 7 over 3. Now, of course, this on a number line, we have 3 and negative 7 over 3. Both are going to get closed circles again. And since I want stuff less than 3 but bigger than negative 7 over 3, I again want the stuff in between here. Okay, now part D, we have that absolute value of x is less than negative 2. All right, now the other number, well, the number on the other side is a negative, so we should sort of pay attention to that, right? So here we want to know, when is absolute value of something smaller than a negative? Well, of course, this is never, right? Because the smallest absolute value would be 0, and smaller than a negative is even smaller. So this one is no solution. Right? Because you can never have absolute value be less than a negative number. Okay, and finally, part E, we have absolute value of x greater than negative 5. All right, now again, we have a negative number on the other side, but this is just the opposite, right? Because we want to know, when is an absolute value of something greater than a negative number? Well, this is always true. Right, regardless of what value you plug in for x, this will always be true. All right, so you could say it's always true. You could say infinitely many solutions, all real numbers, something like that, right? But the point is that this is always true. Okay, so last couple of examples here. Part A, we have the absolute value of 2x minus 6 is greater than 4. All right, so my number on the other side is positive. So I can say that 2x minus 6 is either greater than 4 or it's less than negative 4. And then we just solve each. So I can add 6. And I get 2x is greater than 10, which gives me x is greater than 5. And on this one, I'm going to get that 2x is less than 2, which gives me x is less than 1. Now here, we're going to have to be a little bit more careful when we plot. All right, both are going to get open circles. But now I want stuff greater than 5, so I need to shade this way. And I want stuff less than 1, so I need to shade this way. So I almost get two sort of separate regions here, right? And if you wanted to say this in interval notation, this is negative infinity to 1, but that just takes care of the second part. I also have a part where it's 5 to positive infinity, and I just join them together with a union symbol, right? So that's sort of your solution to this one. All right, in part B, we have absolute value of 5x minus 6 greater than 9. So if I split this, I'm going to get 5x minus 6 greater than 9, or 5x minus 6 less than negative 9. So we can add 6 to both sides, and we get 5x greater than 15. So once we divide, we get x is greater than 3. And then, of course, on this one, if I add 6, I get 5x less than negative 3. So x is less than negative 3 over 5. Okay, so on my number line, negative 3 over 5 up to 3. Looks like both, again, are getting open circles. And I want stuff bigger than 3, so I need to shade this way. And stuff less than negative 3 over 5, so I need to shade this way. And again, if you wanted to put this in interval notation, we're going from negative infinity to negative 3 over 5. And we're unioning that with the set from 3 to positive infinity. All right, one last example before we wrap this video up. We have 2x minus 2 is greater than or equal to 8. Okay, so again, my number on the other side is positive, so we can form our two inequalities. One where we keep the inequality symbol the same and use the positive number. And then on the other one, we'll flip the symbol and we'll use the negative number. So of course we add 2. We get 2x is greater than 10, which once I divide will give me x greater than or equal to 5. Right, and then in the other one, if we add 2, we get 2x less than or equal to negative 6. So dividing by 2 gives us x less than or equal to negative 3. So in this case, both are going to have closed circles. Since we have the equal sign, so closed circle on negative 3, closed circle on positive 5. If I want stuff bigger than 5, I need to shade this way. If I want stuff less than negative 3, I need to shade this way. And again, if you wanted to put this in interval notation, the only difference is now, since we're including negative 3 and 5, I need to use brackets. But again, infinity and minus infinity always get parentheses as well. All right, so that wraps up this video on absolute value equations and inequalities. Hope you enjoyed, and I will see you next time.